Paris mentioned security and the room kind of clears, but hopefully we can keep this fun. So I'm CJ, and this is Tim, and we're going to try to give you a view on the state of security in the Kubernetes world today in what we're calling Kubernetes security through the ages. So I think a lot of us have kind of a vague idea of what Kubernetes security means, but there is no like one place for security. It's not like there's a repo that is the security repo or a binary that is the security component. So whose responsibility is this? So there's SIG-auth, and that's kind of maybe who you think of when you think of security. Nominally, SIG-auth is responsible for authentication and authorization in the Kubernetes control plane, as well as the provisioning of some of the pieces that makes different pieces of the Kubernetes world interact with each other securely. But there's also plenty of other SIGs that are doing very deep security-involved work. So a lot of this work is spread across the many SIGs we have in the Kubernetes community. And then lastly, there's also the Kubernetes product security team, which handles all of the incoming disclosures, incoming vulnerability reports, and then manages the process of building and testing and releasing fixed versions of Kubernetes for any vulnerabilities. But really, it's all of us. It's all of us that are in charge of Kubernetes security. All of us are contributors to Kubernetes. Every PR we submit, every feature we develop is a chance to improve the security posture of Kubernetes. Even as Kubernetes users, as we're building things on top of Kubernetes, thinking about the security implications of the choices that we make is important now, and it's going to be even more important going forward. So this morning, what we wanted to do is take a quick look back. Doing work in security can sometimes be tough. It feels like you spend half your time putting out the ongoing fire, and the other half of your time trying to convince people that the breaking change that you want them to make is actually for their own benefit and worth all the pain that you're making them go through. But we've made a lot of progress, so we did want to call that out. After that, we want to give you a heads up of some of the more recent stuff that's been going on in security, as well as some of the work that is actually ongoing right now. And then we're going to finish up with sort of a broad look ahead and things that we wanted to call out as focuses for Kubernetes moving forward. So if we take a look back all the way to Kubernetes 1.2, because that's the first one that we could find like actual thorough release notes for back in 2016. There was actually security. You could reasonably say there was good security as long as you absolutely trusted every single piece of anything that came into contact with your Kubernetes cluster. There was configurable authentication and authorization. Unfortunately, a lot of it was done statically. It was either flags passed to binaries or config files, which, as we're trying to push this dynamic system of Kubernetes, the static configuration was really just an impedance mismatch. And so what ends up happening is you just ignore that stuff. You make it really easy to work, and you don't take the hit of having to restart your API server every time you want to change authorization policy. And we were trying to push this world where you containerize your processes and then you feel safe from the world around you. And in Kubernetes 1.2, you could do that. But we really hadn't pushed into the realm of how do we control what people are doing through the Kubernetes API. So again, as long as you trusted everybody that was creating pods, you can maybe assume that you were a little bit safe. And then finally, it was a very new world. A lot of the ecosystem, still pretty new, still sort of poking around, figuring out what the right way to think about the security model is. And that leads to a lot of somewhat simplistic ways of building up your security model. The kind of canonical one I wanted to point out is assuming that if someone has access on the network, that you might as well grant them admin access because they wouldn't be talking to your network if you didn't already trust them. So moving from that into more mature. So then if we fast forward to more recent, take a look at Kubernetes 1.12. We're getting a lot better. There's a ton more protections, and as the usage of Kubernetes is evolving, there's a ton of new expectations. So things are much more configurable, much more hardened. But people are starting to use Kubernetes much more broadly. It's not just a little one-team shop where you got the 3 people that you can yell down the hall if Jane, submitted a bad pod spec or something. So thinking about what things look like as we move towards different models of multi-tenancy. So in 112, there's a ton more configuration you can do at the authentication, authorization, and admission layer. And what this really should do is give us the building blocks that we're going to need for a much richer policy environment so that whoever's using Kubernetes, whatever their needs are in terms of API access control and policy, they'll be able to build on top of these pieces. And then there's just a ton of work that's gone into building up layers of defense, trying to figure out what exactly our security boundaries are and trying to enforce them as best we can. Starting to take a look at things as, what happens if this thing is compromised? What happens if this layer doesn't hold? What else do we have there? What can we do to figure out what happened after the fact? And so there's been just a bunch of work on separating out, making those one vulnerability things less harmful. And now it wouldn't be a proper look back if we didn't also consider some of the vulnerabilities that have happened and that we fixed over the past few years. These things happen, bugs happen. Some of them have security implications. The important part is that we're ready to respond to them and that we respond to them sort of in a mature way, and that we can get up here and stand up and look back and kind of have some fun with it after the fact. So the first one, this was probably our first real thing. It might have been the first time we had to go through the process of getting a CVE and stuff. This was a fun one where you could submit a request to the API, maybe with some dots in the name of your resource you were requesting, and convince etcd to give you access to some stuff outside of what you should have had access to. So this one was interesting because it was kind of the first time that we were thinking of, this violates the expectations of what people would think the API is supposed to let you do, and it was the first time we had to go through this process. Another one, there was a vulnerability where you could take real sort of, valid key that you held with a certificate that was yours, present it, but then just shove somebody else's public key into the chain that you presented, and you could authenticate as them. This was kind of our first worst security vulnerability. It was this was still in the time where Kubernetes was, the external shell was the important part. We weren't really considering privilege escalations inside of the cluster as too crazy yet, but this was the first one that really broke that expectation. So then this next one is interesting. There was a vulnerability in pod security policy that through a nicely crafted pod spec, you could actually get access to some privileges with a pod that you shouldn't have had, even if your cluster did have a very well-formed pod security policy. The interesting thing about this one is it's only a vulnerability because of the changing expectations. As soon as we introduce the pod security policy model and the thought of, well, actually, I don't necessarily trust everybody that's talking to my API, then you have to consider that things that bypass those protections are now considered vulnerabilities. So if you just consider the external layer of Kubernetes as your shell, this isn't even a vulnerability, but the changing expectations make this more worrisome. And then this is a similar vein. This is a fun one. You can submit a pod spec that essentially tricks Docker into mounting some host directories that you should not have had access to. There's going to be a talk tomorrow on it if you want more details. Michelle and Jan are giving a talk tomorrow morning, which should be a great talk. And again, this is one where the expectations of Kubernetes actively protecting you from the other tenants in your cluster is what makes this interesting. And then lastly, this one's maybe top of mind for a lot of you. Recently, there was a fun little bug in our proxy handling code where with a specifically crafted request, you could get the API server to open up a TLS connection to a downstream component and then hand that connection right back to you to use however you would like using the Kube API server's credentials. So for example, on an exec request to kubelet, if you form that just the right way, you could get back the TLS connection to just start talking to kubelet. As we've just seen, this wasn't our first serious Kubernetes vulnerability, but it was the first one to really get a lot of traction in the press. There were a lot of articles written about this. And I just wanted to point out, this is the new normal. This is what's going to happen in the future. So we should be ready to respond. We shouldn't be worried about these things happening. They will happen. We think we're ready to respond to them. And with that, I'll hand it over to Tim to talk about some of the more recent stuff going on.
Thanks, CJ. So we've sort of looked at how in early Kubernetes we were really focused on the external perimeter. And then as we got more mature security, we started to look more at adding additional layers within the cluster and starting to think about these multi-tenant use cases. And so this was a lot of the work that we did in going into 2018. And looking forward, it's the focus of a lot of the work in 2019 as well. And so I just want to highlight 3 different features that are particularly cross-cutting across the organization and all SIGs and might affect other work going on. There's a lot of other great security improvements and work happening within the community, but these are just the 3 that we kind of chose to talk about for time. So the first I want to call out is the enhancements to service accounts. Service accounts have been the kind of service identity or the workload identity since the beginning of Kubernetes, but there were a few problems with the way it was implemented before. We have these tokens, that's a static credential, that you can rotate it. It's a pretty manual process. A lot of clients aren't really equipped to handle that well. And with the enhanced service accounts, they now have expiration built in. The kubelet will even handle auto-rotation for you. So if an attacker steals those, then they can't use it forever. The second thing is the original service accounts were shared by all things running under that service account. This meant that from the purposes of audit or from the control plane, it all looks like the same thing. But if an attacker manages to compromise one pod in that workload, they might be able to compromise that node. So for better auditing, we now have per pod identity information that's added in there. We might be able to do more fine-grained authorization off that too. And then the last one is audiences. So you can use a service account token not only to talk to the API server, but to talk to another service. If that service implements token review, they can sort of delegate the authentication task to the API server. The problem is that other service now has the requester's identity token, and they can do anything as if they were that identity. Audiences aims to fix this by saying this token is only meant to talk to, say, the metrics server. Now the metrics server can't use that to talk to the API server because it's only for that one service. And so token request, kind of the basics of these new service accounts went in 1.12 as beta. I guess it was alpha before that. And starting in 1.13, you can now auto-mount these things in place of the old service accounts. We'll be kind of thinking about how to roll this out in 2019, but there's some kind of subtle discrepancies between how these new ones work and the old ones worked. And there's 2 sessions later in the conference if you want to learn more about this in detail. The second one I want to call out is near and dear to my heart, which is Sandboxes. With most kind of host container sandboxing, there's a lot of mechanisms in the kernel that are used to harden the container boundary. The problem is it's all still through the same kernel. So even though it's a smaller attack surface, a single kernel vulnerability can lead to a complete node compromise. With Sandboxes, the goal is to add a second layer of security boundaries so that no single vulnerability can lead to container escape. And we're doing this by working with runtimes like gvisor, Kata containers, and Windows Hyper-V. On the Kubernetes side, this looks like a runtime class feature, which lets you select between different runtimes. That was alpha in 1.12. And we're looking to kind of move that along in 2019 and add some future improvements there as well. But it's not enough to just harden the kernel attack surface. There's a lot of other attack surfaces exposed in Kubernetes. And so another example is through volumes. So if you just kind of take Kata containers today, and we're running that with an older version of Kubernetes, the symlink vulnerabilities we mentioned earlier would actually be exposed into, you could potentially mount host volumes into the container. So we need to think about how do we harden that volume interface to make sure that no single vulnerability there can compromise it. Similarly with the networking side as well. There's a lot more sessions on this. Check out the runtimes track. There's too many to list in one slide. I tried, but a shameless plug for my own talk, where we'll talk about Sandboxes a bit more in detail. And the last one I want to call out is node isolation. So node isolation has actually been in Kubernetes since 1.7 through the node authorizer and node restriction plugins, which maintain a graph of which resources are needed by which pods, which run on which nodes. So this means that we can use a least privilege model for the kubelet and say, hey, you kubelet, you're not running a pod that needs the secret, so we're not going to give you access to that secret. The problem is there's this attack where the attacker can kind of steer workloads to that node by manipulating scheduling constraints and then, say, DOSing that service, forcing it to reschedule. Once that workload gets scheduled onto the node, it now is granted access to that secret. So to prevent this, in 1.11 and 1.13, we started to lock down what kubelet is allowed to self-modify in terms of scheduling constraints. But this has all just been focused on the kubelet identity so far, but an attacker who has control of the node can access any identity of any workload running on that node. So kind of next year, we're starting to think about how can we apply some similar constraints and restrictions to daemon sets and other system workloads, and then also starting to think more about reducing visibility into the entire control plane, and locking down things like logging and monitoring as well. So we wanted to kind of wrap up by talking about some really gnarly issues that remain in Kubernetes that we really need everyone's help to fix. This isn't something that we can just address in SIG-Auth or the product security team. And the first of those I want to talk about is the vendor dependencies. You might recognize this story from the top of Hacker News about 2 weeks ago, where a NPM library got backdoored, and this was used to attack various crypto mining kinds of applications, and I assume run off with their cryptocurrencies. But this would never happen in Kubernetes, right? You all, I'm sure, review every line of code that gets vendored in, all 1 million of them, from over 250 different repositories. Let's see. And so that's, clicker dead. Oh, there we go. So this is only thinking about a malicious attacker, right? They've backdoored something, and yeah, we might be able to catch that. But we just talked about earlier how just software bugs lead to vulnerabilities. This is where most vulnerabilities come from. And kind of the security, the good security operations is to just patch all the time, right? A vulnerability comes out, no problem, patch it, okay, we're good. So in Kubernetes, we haven't been doing this. This is just a selection of like our top 20 stalest dependencies. These are things that are actively developed, and we haven't updated them in over a year. There are almost 1,000 commits behind head. So it's a problem. So what can we do? We should think about whether we actually need to vendor everything that we're currently vendoring. We're starting to do things like break cloud providers out of tree into separate repositories and separate plugins. But this comes with another problem of now we have 150 different repos all vendoring different versions of things, and we want to make sure that everything stays patched and up to date. Also increasing visibility of what changes are going in upstream and making sure we have good ownership over these dependencies to keep them up to date. So the next issue I want to talk about is secure defaults. We mentioned this a little bit earlier, but why is this so hard? I think Brian touched on this a little in his presentation, but changing a default is always a little bit contentious, but particularly so with security defaults, which a new security feature is almost by definition a breaking change. If what we're trying to do is prevent an attacker from doing something, but maybe we're also preventing a developer who is using that feature innocently, right? And so we need to kind of think about how do we go about breaking everyone in the name of security. And just to throw out a few cheeky examples, I recently learned that the Kube API server and the kubelet actually default to authorization mode always allow in the flags. That was alarming. Containers run as root, and the API server ignores the kubelet's public certificate signing. So what can we do about this? The first is kind of like preventative. When you're adding a new feature, think about what the security implications are. Oftentimes it's easiest to just say, oh, we'll deal with security later, but this ends up being a lot more work in the long run. But also, I mentioned on the previous slide that these are kind of cheeky examples because most people aren't really configuring based on just like the default flag values. Usually they're going through some tool or a cloud provider. The problem is the defaults that those cloud providers and tools are using are all different from each other. And so we want to try and align the defaults across these different things so that the user doesn't have to actually understand every setting to know that they're checking the right boxes. And one way we've been talking about doing this is through security profiles. This is still kind of under discussion. But the basic idea is to have different profiles for different levels of security and then be able to share those configurations across the ecosystem. And finally, I want to talk about just scaling the org. We now have almost 150 different repositories in Kubernetes organizations. And there's no way that the product security team can maintain expertise in all 150 of these. So the first thing we're doing is, you may have noticed that every repository now has a security contacts in the root. These are people that we can go to help us triage vulnerabilities and to kind of help us with the release for that component. But also, it's important to pay attention to security as you're reviewing PRs. In particular, just kind of think about what's the worst that could happen if there was a bug in here. And don't be afraid to ask for help if you're not a security expert or just want a second set of eyes on some sensitive code. And then kind of the third piece to mention, we've learned this along the way of doing Kubernetes security releases, but investing in the release infrastructure up front if you're not part of the Kubernetes release train will pay dividends later. Think about how fast you could patch a critical vulnerability and whether you're able to patch those things in private. And to help us kind of find more vulnerabilities in the system and just keep these things kind of at bay, we're trying to launch a Kubernetes bug bounty in 2019 to reward security researchers for responsibly disclosing vulnerabilities to us. Yeah, so in conclusion, we've come really far from Kubernetes 1.2. We've got much better security than we did back then, thanks to the hard work of the community. We've still got a lot of work left to do, and we need your help for that. So with that, thank you.
Questions?
Can you give us an update on what the status of the current exposed vulnerabilities? Are they making it into CI and testing, the ones that we know about to ensure that we're not regressing?
The status of what? Sorry.
I'm sorry. No. So when we have a vulnerability and we patch it, there's normally a penetration test that goes along with that can exploit the vulnerability. Are those tests going into the current CI system? Before I asked this question, I actually bugged Aaron, who just happens to be sitting next to me. And he didn't know the answer to the question, so I figured if he didn't know and I didn't know, we should probably ask the
We also
question.
got Jordan right behind you.
And Jordan. Here, you can answer.
The answer is yes. When we have embargoed fixes, we have tests for that. We have a private repo that is running a parallel set of CI tests. We have tests that demonstrate the vulnerability and demonstrate the patch fixes the vulnerability. Those tests, depending on the severity and how clearly the test demonstrates how you exploit the bug, sometimes those tests get picked into the public branch later.
But once it's been exposed.
Once it's been exposed.
Knows, are all of those tests being moved into the?
Yes. But yes, the answer is the tests, there are tests demonstrating vulnerability and fix, and those all eventually end up in the master public branch, yes.
Shouts to Jordan on that awesome issue for keeping everybody update too. Holy crap. I was like, it was closed and I was like, is this thing still going? I was like, wow, Jordan's awesome. All right, last questions. We are over time. One more, Matt.
So with the vendor directory and the dependencies, and we've got lots of things out of date, and many of the things we have in there aren't even pinned to release versions. They're just random commits in between. Are you working with SIG architecture, or is there any plan to figure out how to correct any of this problem?
So I don't know of any plan at the moment. This is something that I'm trying to work with some other teams to get staffed up in 2019. So I'm hoping that we'll see a plan emerging soon, but I don't think there's one yet.
Yeah, the SIG architecture code reorganization is especially for this, so we can do the work there.
Yep.
Steering.
Where can people contact you if they have more questions today? Are you hanging out anywhere?
I'll be around, yeah.
Contributors.
If you have any more questions, Contributor Summit Slack channel, and they will meet you in the Contributor Lounge or some other place.